Good morning, class. Today we're going to be doing lesson number 6, area review. Just to kind of wrap up the area unit we're working on and make sure we're kind of filling in any gaps in your knowledge. Last class, so Wednesday, we went into volume a little bit, just so we could look at the difference between surface area and volume. So once we get to volume, we're going to be dealing with the amount of space a 3D shape takes up. But when we're looking at area, we're just looking at the amount of space a two-dimensional shape takes up. So a two-dimensional shape, if you imagine like your bird's eye view looking down everything, you see everything just in like a flat space. And that's just going to be your area. It doesn't have a depth to it, it's just a surface. So when we're finding our areas, we're going to be using three main shapes: a rectangle, a triangle, and a circle. These three shapes are going to help us solve our area problems for everything that we're going to be doing. So our rectangle is going to have two dimensions to it, a length and a width. The width is going to be the length of two sides, and the length is going to be the length of the other two sides. So to find the area of this rectangle, it is the width multiplied by the length, or the length multiplied by the width. And that's going to give you your area of a rectangle. So any rectangle, you can find the area using this formula. This formula is available to you on your formula sheet that I post in Google Classroom a couple times. If you're having trouble finding it, just send me an email and I can send you a formula sheet. The next shape is the triangle. So a triangle is pretty much half the area of its rectangle. So if we were to take a rectangle that has a base the same as the length, and we were to fill it in, and it's going to have the width the same as the height, the area of this rectangle would be the base multiplied by the height. But because we're just doing a triangle, it's going to be half the area of that rectangle. So it is going to be your base multiplied by your height divided by 2, because the side here we're missing and the side here of the rectangle are going to be the equal sides of this triangle, if that makes any sense. So a triangle is going to be half the size of a rectangle. That is why we divided by 2. For a circle, it's a bit different. We're only going to need one dimension of a circle. We need the radius. So the radius is from the center of the circle out to the edge. Now the diameter is a bit different. The diameter is all the way across the circle, and the radius is just going to be half of the diameter. For area, we don't want to use diameter. We commonly use radius. So our radius is going to be from the center to the edge. Now our area is going to be pi, which is 3.14, times r squared. So we got that radius squared. Because we are using area, we're taking the space of a two-dimensional object. Our units shall be two-dimensional. So we're squaring our dimension we have, radius. So pi times r squared. This is the same as saying we have pi times r times r. So all these shapes are going to be, or we're going to be able to break down every shape into these three shapes. So I tried to draw an example here, but I didn't like how it looked, so I drew a different one here. So here, we have this one weird looking shape. And we could break it down into different shapes. So first, we can look, okay, there's a triangle on the top here. I can draw a line here. And I'm going to separate my triangle and a so-called rectangle. So looking at this triangle first, the shape says it's going to be 1 centimeter tall. So I know my height is going to be 1 centimeter. So my height is going to be 1 centimeter. My base is going to be 3 centimeters, because that's the length at the bottom here. And that's going to be the same length as the top of the rectangle. As we can look in our rectangle diagram, the bottom length is going to be the same as the top length. So we know our triangle is base of 3 centimeters and a height of 1 centimeter. Now, we can also look at the rectangle that we have here. There is a part cut out of the rectangle, but we can just ignore that and we can go back to that. So the rectangle we're going to have here is going to be 3 centimeters wide and 3 centimeters long. So we can draw it out down here. We got one rectangle that's 3 centimeters by 3 centimeters. So far we've broken the shape down into a triangle and a rectangle. But we are missing half of a circle here. So what we can do is we can remove the area of that half a circle from our area of a rectangle to get the remaining area that we have left. So we go to the next page. There we go. Okay, so we have a half circle here that we want to remove. And we know the diameter of the half circle is going to be 3 centimeters. But we want to remember that we don't want to use the diameter when we're finding area. We want to use the radius. So to find the radius, we're going to divide the diameter in half. We want to go from the center to the edge. So half the diameter. So that means our radius is going to be 1.5 centimeters. Now, when we're finding the total area of the shape, we have a triangle. So the area of the triangle, and we're going to add the area of the rectangle, but we want to minus the area of the half circle. And we're removing it because on the shape, it's gone from that space. So we're going to take that area away from our rectangle. So I actually made a mistake here. I did not divide the half circle by 2. So I'm going to go ahead and do that now. And then hopefully I'll fix that on the notes that I give everybody. We're going to divide this whole thing by 2. So the area of our triangle is going to be using the formula our base, or our height, times our base, divided by 2. We're going to add the area of our rectangle, which is going to be our length, times our width. And then we're going to take away area of a half a circle. So we're going to find the area of a circle. We're going to divide by 2 because we're just using half of that circle. Okay, so doing that equation, we have 1 centimeter squared plus 9 centimeters squared. We're going to have minus 7.07 centimeters squared divided by 2. And I'm just going to go ahead and erase this. So this is going to give us 10 centimeters, adding the area of the triangle and the rectangle together, 10 centimeters squared, minus 3.54. I'm just rounding up that 3.5 before there. Centimeters squared. It's a bit messy here, sorry for that. And this is going to give us that's a sits point. What is it? 4 centimeters squared for area of our shape. Okay, so that kind of wraps up finding the area of a shape that's just made up of the 3 different shapes that we know. But we can look at maybe a more concrete example when we're trying to find the area of regular polygons. So if we remember, regular polygons are going to be shapes where there's a certain number of sides, and each side is the same length, and it's going to come together back to form somewhat of a circle, but with edges, if that makes any sense. So looking at polygon here, we have 5 sides. So this is going to be a pentagon. We're given the side length for one side, and we know that each side length is going to be the same. So we say the base of it is going to be 2 inches. So each side length is going to be 2 inches. And then from the bottom of the base to the center is going to be 4 centimeters. So a couple things to look at here is we can break the shape down into 5 triangles. Each triangle is going to have the same dimensions. It's going to have a base of 2 inches, a height of 4 centimeters. The second thing to look at is we have different units, so we're going to have to convert that at some point. Okay, so I'm going to give you the steps on how to, when you see a regular polygon, how to solve for its area. So the first thing you want to do is you want to count the number of sides you have. So we have 5 sides in our pentagon. Next, let's find the dimension of one of our triangles, just so it looks a bit neater. So I've drawn this out again. So we got 2 inches by 4 centimeters. Now, step 2B is let's make sure our units are the same. So I'm going to convert my inches into centimeters. So I have my conversion that 1 inch equals 2.54 centimeters, or 2 inches equals 5.08 centimeters. So now my triangle is going to be a base of 5.08 centimeters and a height of 4 centimeters. So the third step is we want to find the area of one of our triangles. So the area is going to be our height times our base divided by 2, or 4 centimeters multiplied by 5.08 centimeters divided by 2, giving us 10.16 centimeters squared. So we want to make sure that we're squaring those units because we're multiplying centimeters by centimeters. So it's centimeters squared. Our last step to find the area of our total, or the total area of our shape, the area of our pentagon, is we're going to multiply our area of our triangle by the number of sides. So we have 5 sides. So we're going to multiply 10.16 centimeters squared by 5, giving us 50.8 centimeters squared as our final answer. Okay, so moving to the next page, we're going to have to erase this all. So moving into surface area. So surface area is a bit trickier because we're working with a 3-dimensional shape now, a shape that we would see as like 3-dimensional. So it has a length, width, and a depth. So to find the surface area, we want to draw the net of the shape. So to do the net, we want to break it down into its edges, or the outside of the shape. So here, we have a cylinder. It has a base that is a circle, a top that is a circle, and then the shape that goes around it. So if we imagine we put a cylinder down, we roll it. As you roll it, whatever is hitting the ground is going to stay. So what we end up getting is a square that has the height of the cylinder and a length that is the circumference of the circle. And then if you imagine the tops just kind of come down, so we get the first circle and we get our second circle. So now I labeled the edges. We got our first edge, which is going to be a top circle, our second edge, which goes all the way around, which is going to be our second rectangle, and then the third edge, which is going to be the bottom. So finding the surface area, we're going to add up all these shapes together. So we got our area of shape 1 plus our area of shape 2 plus our area of shape 3. Putting the equations in, so area of a circle, we know is pi times r squared, plus our length times our width, which is going to be 2 pi r, that's the circumference of the circle, the length of that rectangle, multiplied by the height of the cylinder. And then we're going to add the area of the circle below, shape 3, which is going to be the same as shape 1, pi times r squared. Okay. So whenever we're in surface area, we want to break the shape down into the basic shapes. So the 3 shapes that we have: circle, triangle, and rectangle. We want to find the area of each of those shapes, and then we add all the shapes together. That's going to be our total area, or our surface area. All right. Hopefully this is a pretty good review on what we've done. I'm going to go over some more questions on surface area on Tuesday's group chat. Even if you don't have questions, I would like everybody to join just so they could kind of see what's going on, and I could touch base on with everybody as well. So hope you have a great weekend, and I'll see you all on Tuesday.